In this lesson, we will reduce complex rational expressions which have repeated non-reducible quadratic factors in the denominator to partial fractions. Let's get started with the given expression. The given expression is 4x square over x square plus 1 whole square into x minus 1. Like before, for every quadratic factor in the denominator, we introduce two constants, one with x and one without x. So if we continue that trend, this will be 4x square over x square plus 1 whole square into x minus 1 equal to ax plus b for the quadratic factor x square plus 1, and because it is repeating, we are going to introduce two more constants, cx plus d, for the repetition. That would be x square plus 1 whole square, and then for the linear factor in the denominator we introduce one constant, which is e, divided by x minus 1. So now let's take LCM on right hand side, and then we'll cancel it out with the denominator on left side. This will give us 4x square equal to ax plus b into x square plus 1 into x minus 1 plus cx plus d into x minus 1 plus d plus e into x square plus 1 whole square. Let's call this as equation 1. We can get value of e by substituting x minus 1 is equal to 0 because x minus 1 is a linear factor. To find e, put x minus 1 equal to 0. This means x equal to 1. So if we substitute this in equation 1, from equation 1, 4 times 1 square is equal to, everything else will become 0 because x minus 1 is present in the first term and in the second term. So this will be 0 plus e into 1 square plus 1 whole square. This will be equal to 4 equal to e into 2 square. So that will be 4 as well. This means the value of e will be equal to 1. We have found the value for e. Now we will be comparing coefficients for the highest powers of x. Now we compare coefficients, for higher powers of x. And what are those higher powers of x? The greatest power of x that can appear in equation 1 is x4. So we are going to compare coefficient of x4, x cube, x square, x, and if necessary, then 1 as well. So, but before we do that, we should first of all expand those terms so that comparison of coefficient is easier. So let's expand this term ax plus b into x square plus 1 into x minus 1. So this will be, since ax plus b into x square plus 1 into x minus 1, and let's expand it. This would be ax plus b into x cube minus x square plus x minus x square plus x minus 1. And now when we multiply it, this becomes ax4 plus minus a plus b into x cube plus a minus b x square, a minus b x square plus minus a plus b plus minus a plus b x, and then minus b at the end. So this is expansion of the first term on right hand side, and let's similarly expand the second term. So this was coefficient of, it's okay. So now the second term is cx plus d into x minus 1. Similarly, cx plus d into x minus 1. If we expand this one, this becomes equal to cx square plus d minus c x minus d. And the last term, this is e into x power 4 plus 2x square plus 1. So in that it becomes equal to ex4 plus 2ex square plus 2ex square plus e. Now it will be relatively easier for us to compare coefficients of x4, as there is no x4 on left hand side. So 0 is equal to coefficient of x4 in this is a. There is no coefficient of x4 in second term. There is a coefficient of x4 which is e here, and we have a plus e equal to 0. But because e is already known, therefore a plus 1 equal to 0. This means a is equal to minus 1. So now we have two values, a and e as well. And we are done by comparing coefficients of x4. Now we will compare coefficients of x cube. So this was for coefficients of x4, and now we will compare coefficients of x cube. And for comparison, there is no x cube on left side, so again the coefficient of x cube will be 0 on this side, and on the other side it will be x cube is here in minus a plus b. So this is minus a plus b in the first term. There is no x cube in the second term, and there is no x cube in the third term as well. So that's it. And This means 0 plus A is equal to B. Means B is equal to -1 as well, because B and A are equal. So now we got A, B, and E, and we are done comparing coefficients of x4 and x cube. Now it's turn to compare coefficients of x square. And this time, when we compare coefficients of x square, there is, in the first term, there is A minus B, that is coefficient of x square. So here it is A minus. Okay, on left side, this is 4 equal to A minus B, A minus B, and in the second term, the coefficient of x square is C, and in the third term, the coefficient of x square is 2e, plus 2e. And now by substituting the values of A, B, C, and E, this will give us 4 equal to A is -1 minus -1 plus C. C is that we need to find, plus C plus 2 times E. E was equal to 1, so this is 2 times 1. Therefore, this 4 is equal to -1 plus 1 plus C plus 2. Here, this plus 1 is cancelled with -1, and C is equal to 4 minus 2. This means C is equal to 2. So we have found another constant, which is C, and this was the result of comparing coefficients of x squared. Now we will compare coefficients of x. And there is no x on the left side, so 0 is equal to, from the first term, if you take a look, coefficient of x is minus a plus b. So this is minus a plus b, and in the second term, the coefficient of x is d minus c, plus d minus c. So now if we take values of a, b, and c, and then put those values in this equation, 0 is equal to minus, a is again -1, so -1 plus, okay, b is -1 plus d we don't know, but c is -2. So 0 is equal to 1 minus 1 plus d minus 2. Minus 1 is cancelled out with plus 1. This means d is equal to 2. So now we got all the values of the constant a, b, c, d, and e. Substituting these values, values of a, b, c, d, and e in defining equation. We have 4x square over x square plus 1 over x square plus 1 whole square into x minus 1 equal to, what was the value of a? That is minus 1, so this would be minus x plus b is minus 1 over x square plus 1. X square plus 1, and value of c is 2. So 2x plus d is 2 again, plus 2 over x square plus 1 whole square, and value of e is 1, so plus 1 over x minus 1. This is, in fact, we can write it minus x plus 1 over x square plus 1 plus 2 into x plus 1 divided by x square plus 1 whole square plus 1 over x minus 1. This is how we can reduce any kind of rational expression into simpler rational expressions or simple rational fractions, and this technique is very helpful in performing derivatives and integrals when it comes to do so in calculus. We'll see you in next lesson.